We're going to look at making small changes in a path analysis model. Talked about these steps. We're still kind of looking at possible revisions and how we might change our path analysis model. And so one of the ways to look at it is to look for the weak link. And so if you were to look at this, which one of these would seem kind of lower than the others? I'll give you a second to look at them. These are standardized values. So you might notice that, and this is a fully identified model, that this relationship right here seems to be the weakest link of the rest of this model. So we might think maybe our model would be better without that relationship. Well, let's check it out. So one of the ways that we can do that is your software will provide you with t-values associated with each of these relationships. So it's similar when you do a multiple regression. You'll get a p-value associated with every relationship, and you'll be able to see if that relationship is significant from 0. Well, so let's look at the t-values. So for most of these, they look fine. That would be significant from 0 as a relationship. But then if you look at over here, we have 2 that, and they tend to highlight them in red, that are below the significance threshold. So maybe one or both of these should be eliminated. But since this one is quite a bit lower, we'll start with this one for now. And because you don't want to eliminate a bunch of relationships all at once. You want to do it one at a time so that you can kind of assess the effect that eliminating one is going to have. Okay, so let's look at deleting this relationship. And so you go, if we went in there and did that on our software, here's what our new model would look like. And you've kind of already seen this along with its values here, down here at the bottom. And so, but these models, this model looks pretty good, and these relationships are quite a bit stronger. Um, well, but could it be made a little bit better? Well, let's check it out. So, going back to the t-values, looking at the new t-values, we still have this one that is below our threshold. And so we might have some concern about that, and that's between taking the test and the dogfighting skills, which from a theoretical perspective we talked about is actually pretty important. So this is something we've got to figure out. So if we took out that relationship, you can see right here there's no longer an arrow between test and dogfight. Here's what our new model would look like. And test is kind of just out there on its own, although it is predicted by these two variables, as you can see by these relationships. But need is the only factor related to dogfighting. Well, unfortunately, what you can see, if you compare this new model to this previous one, it's actually not as good. Now, the chi-square value did go down, and the p-value went up, but also the RMSEA, or root mean square error of approximation, went up. And so since we want our RMSEA to be low, it seems like this model is not as good as the previous one. That as far as fit for the data, the other one, this one right here, fits a little bit better. And so, but we still made some small changes, and I went ahead and this one I swapped the location of need and family because I felt like that made more sense in the look of it. And these are the standardized values that we have that look at the relationships between these. So he says, hey, so it helps. So it looks like I was right. It says Maverick, the need for speed does help predict better dogfighting skills. But then she says, well, it seems like both need and test factor in quite a bit. I guess we should consider both of them instead of just the test, as we have been for some time. But we have, oh, it's Viper. He says, so which of these factors matters the most? Should we even consider family? It seems like it is not very strongly related. Well, we're going to look at that later and we're going to talk about both direct and indirect effects that we can model from these different variables. And that's pretty interesting because it's one of those things that you can do in path analysis that you can't do in a lot of other types of things like multiple regression. So should be pretty interesting.